Now the basic of this, the smallest addressable unit in a computer is called as a word. So what is it? Word. You might have heard about this one, right? Word. So even though there are bytes, we rarely have byte as the basic addressable unit, which means we count the memory in terms of the words, and we count everything in terms of the word, size of the entire memory, or size of the page, or size of the process. What is a word is the smallest addressable unit in a computer is called as word. And why are we interested in words? Because depending on the number of words we have, the addresses are going to depend on that, and depending on the addresses we need, the address size in bits is going to depend on that, right? So what is a word? The smallest addressable unit in a computer, right? And how does this concept of word come into picture is, maybe if you remember this RAM, the concept of RAM, right? There is a decoder, and decoder is going to be given some input. You please refer to the digital where I have discussed about the concept of RAM there, right? And it is, let us assume that it is a 4x16 decoder. So what is RAM? It is a combination of maybe let's talk about, instead of talking about RAM, let's talk about ROM first, right? What is a ROM? ROM is a combination of this this decoder and then this one, right? And then the matrix, isn't it? So let us say is 4x6. Now these this entire part is nothing but the data, and this entire part is nothing but the address, right? So whenever you give it some address, one of the line is going to be activated, and whenever you activate one of the line, how many bits will come out, that will depend on number of the vertical lines. You please refer to the digital and again come back here, only the ROM concept. What I mean to say is, whenever you give the memory unit some address, it is going to give you as output some number of bits. It is not just going to give you 1 byte. It might give you sometimes 2 bytes, sometimes 4 bytes, or sometimes just 1 byte. So in that case, one address is going to give you those many bits, right? And all those bits are collectively going to form as word, which means there is no way you can read anything less than that, because your system is configured in such a way that you give it some address, it is going to give you some fixed number of bits, and that is called as word. Got it? And sometimes what happens is, the number of bits that comes out will be 8 bits, then it is nothing but one word equal to 1 byte. And sometimes 16 bits will come out. In that case, one word equal to 2 bytes. Sometimes 32 bits will come out. Then one word equal to 4 bytes. So depending on how many bits are going to come out, whenever you give it some address as the input, we are going to define a word, and the word size can be anything, right? And now once you define the word, then you can define the addresses, right? Let us assume that we have the main memory here, which is RAM, which is made of flip-flops. We have main memory, and in the main memory we have 128 words. If 128 words are there, then in order to address each one of them, how many bits are required? Log 128 base 2, which is nothing but 7 bits. Got it? So depending on the number of words, we are going to derive the number of bits required in the address. So I think you understood the concept of words. Now let's go back to the concept of paging, right? So before going ahead, now there are some terminologies which you should be knowing about. So one is called as physical address space. The physical address space is nothing but size of the main memory. So generally they will give it in words, right? In case if they don't give it in words, it is better that you convert it into words. So sometimes they will say that the physical address space is let us say 128 KB, 128 kilobytes, right? Then how much is this? 2 power 7 into 2 power 10 into bytes, right? So what is it? 2 power 17 bytes. This is what they are given. And now they might say that word size is 4 bytes, right? Then how much is this? 2 power 2 bytes. Then if this is the case, then what is the size of the physical address space in words? Physical address space in words equal to 2 power 17 divided by 2 power 2, which is nothing but 2 power 15 words. Got it? And once you find out the number of words, then you can find out the number of bits required in order to address each word, right? If I have 2 power 15 words, then how many bits are required to address each one of them? 15 bits, isn't it? Then in that case, physical address, this is called physical address. Physical address is going to be 15 bits. Got it? So always find out the physical address space in terms of words, and once you find out the physical address space in terms of words, then you can find out the number of bits required in the physical address, right? So in general, if physical address space is going to be, let us say, right, then physical address, which means number of bits required in the physical address, is going to be log m base 2 bits, right? This is the physical address, right? And similarly, there is one more concept which is called as logical address space. So logical address space is nothing but the size of the process. So what is physical address space? Size of the memory, main memory. Logical address space is size of the process. Why is it important? Because sometimes your space, your process might be smaller than your physical address, or your process might be larger than the physical address, right? And we have to take care of both of them. So next one is called as logical address space. So what is logical address space is equal to size of a process, and this number varies from process to process because every process can be of different sizes, right? So let us say logical address space is equal to 256 MB, megabytes, and now you find out the word size. Word size will be given already, right? So what is 256 MB? 256 is 2 power 8 and M is 2 power 20 and bytes, so which is nothing but 2 power 28 bytes, right? And then you can find out the word. Let us say word size is given as the same thing, 4 bytes, right, which is nothing but 2 power 2 bytes, right? Then what is logical address space in terms of words? 2 power 28 divided by 2 power 2, which is nothing but 2 power 26 words, right? So once you find out the logical address space in words, then you can define the logical address. Logical address is nothing but number of bits required to address the logical address, right? Now logical address is number of bits required to address these many words, right? Then how are you going to find it out? And then if 2 power 26 is number of the words, then obviously it is going to be 26 bits. So 26 bits is going to be required in order to address the logical address. Understood this? So in general, if logical address space is equal to let us say L words, then what is logical address? The size of logical address is going to be log L base 2 bits. Got it? So what is the relationship between logical address and physical address? Actually there is no relationship. That is the size of the memory and is the size of the process, right? So earlier what used to happen is we used to always have programs or processes whose size is less than the main memory. Then what happened was the entire process could be loaded in the main memory and it could run. But later what happened is the size of the process have become so large that they are not able to fit in the main memory, right? So watch it. What happens here? If the physical memory is only 128 KB, but if the process size is, what is logical address space? Process size. Process size is 256 MB. Obviously we cannot place it in the main memory completely, right? Then the concept of virtual memory has come into picture. So what is virtual memory is, you can run a process even without having the process completely in the main memory. You can have only partial part of, which means only some part of process you can have it in the main memory, and still you could be able to run it. That concept is called as virtual memory. And when is it going to be useful? This is going to be very useful whenever the size of the process is very much higher than the main memory, right? That is how the virtual memory concept has been introduced. So what is virtual memory? The concept is simple. Whenever you can make a note of it, whenever the size of the process is larger than the size of the main memory, we are going to put only a part, which means partial amount of process in the main memory, and we will be able to run it. That is called as virtual memory. So initially it has been proposed in order to handle the cases where the size of the process is very much higher than the size of the memory available, but later it has been used to take the advantage of increasing the the degree of multi-programming. Now even though the processes sizes are less than the size of the main memory available, still we try the amount of each process. So now virtual memory concept has been implemented to increase the degree of multi-programming. I don't know whether you are following it or not. Just watch it. Here I'll explain you. See, why was this virtual memory concept was introduced is, initially in the earlier days, whenever you have main memory size like this and the process size like this is the process, and obviously process size is greater than main memory size, and we will not be able to place entire process into the main memory to run it. But then at any point of time we require only a part of the process, not the entire process, right? And therefore we are taking a part of the process and then we are loading it into the memory and we are running it. So this concept is called virtual memory. Virtual memory is having a part of the process in the main memory, not the entire process, to start running. That is called virtual memory. Till now we have never seen anything like this, as we have seen it in overlays, and overlays is handled by user, not by the operating system. Now virtual memory concept is implemented by the operating system. You need not know about it, which means a programmer will get a illusion that lot of memory is available at his disposal. So according to programmer, he can think that infinite amount of memory is available and he can write the program of any length, and operating system will take care of the limitation. If the physical memory is less than what is the memory given available for a process, then operating system is going to implement the virtual memory concept. Got it? And later what happened is, even though the process is able to fit in the main memory, see right now maybe you have seen it, even in a mobile phone, in a small mobile phone, the RAM available is 128 GB, isn't it? So like that the processors are having the computers are having the technology so big, technology is developing so fast that the size of the RAM available in the devices is going to increase, right? Therefore the main memory sizes are increasing. So there is now the main memories are going to be larger than the process sizes, but still virtual memory concept has been implemented. Why is it used is, now even though the process size is let us say this is main memory and these are the process, even though the process's size is less than what the main memory size is, we are still having a part of the processes run in the main memory or load in the main memory at any point of time, because by doing this we can have as many processes as possible inside the main memory. Then what is the advantage? We can increase the CPU utilization by increasing the degree of multi-programming. Got it? So virtual memory concept can be used either when the process size is bigger than the main memory or when the process size is smaller than the main memory. Whatever it is, the advantage that we get is we can have many processes present in the main memory at the same time, and so increasing the degree of multi-programming and therefore the CPU utilization. Understood this? So that is how this virtual memory has been implemented. Now in the light of this virtual memory, what happened is, sometimes this logical address space is also called as virtual address space. And this logical address is also called as virtual address, and these two words are now in use interchangeably. Strictly speaking, they should be different, but the computers have evolved so much that they are using virtual address at all the places, virtual address space at all the places, irrespective of the sizes of physical address and logical address. In general, the strict concept should be like this: whenever the logical address space is greater than physical address space, then we should call it as virtual address space, and the logical address should be called as virtual address, right? But since we are going to apply this virtual memory concept everywhere now, irrespective of the size of the main memory and the process size, these two names are actually used interchangeably. So now from now on, either I say virtual address space or logical address space, virtual address or logical address, you should think that everything is same. Got it? Fine. Now you know about a process size now and the main memory size. Then the next concept that comes into picture is what is a page size or a frame size. Now I told you that already page size or frame size are same, isn't it? So now we are going to divide the main memory into many small parts, and each part is called as a frame, and we are going to divide the process into many small parts, and each part is called as a page, in such a way that page size is equal to frame size, right? Now let us assume that page size is equal to frame size is equal to p words. If these many words are present in the page or frame, right, then how many bits are required to address each word? So number of bits are required to address each word within a page is log p base 2, right? These many bits are required in order to address a bit in each page. This is also called as page offset. Page offset. Page offset is nothing but in order to address each word in a page uniquely, how many bits you should be using. That is called as page offset. So in this case, the page offset is nothing but log p base 2 bits. See, to take a small example and explain you, let us assume that page size is 1k words, right? Or in terms of bytes and then words. Generally they will give directly in words, but then I just want to make it clear what is the difference between words and bytes. Let us say page size is 4 kilobytes, right? And the word size is 4 bytes. Then how many words will be present per page? Then page size in words will be 1 kilo words, right? Which is nothing but 2 power 10 words, right? Then how many bits are required in order to address each word? So in order to address each word, the number of bits required will be 10 bits, right? Right? So okay, generally the concept is page offset. Let's use page offset because word offset is sometimes used in order to find out a byte within a word, right? So let's make it page offset only. Page offset, right? Or sometimes frame offset. Both are same. Let's keep it as page offset. Here the page offset is 10 bits, which means 10 bits are required in order to address each word in a page uniquely. Got it? So now there is something called as physical address space, logical address space, and the now, okay.